Hello and welcome to my Engineering 150 Capstone project demonstration. For this project, our task was to create a device which can measure the distance between two cities on a map. Now obviously this instruction is a little bit vague, so we took some creative liberty. See, tracing the distance between two cities on a map as the crow flies or straight is an easy task to accomplish with pretty much any straight edge, such as a ruler, a piece of string, or even a toothpick. All we need to do is take our straight edge and put it between the 2 points we wish to measure, mark them out, and using the scale on our map, we've actually found our distance. It's pretty simple stuff. So to make this challenge a little bit more interesting, we decided to create a device which can actually measure the route between two cities on a map. As you can see, while we're trying to trace the distance between these two cities using the roads, we have sections of the road that are curved, we have sections that even turn corners, and sometimes they'll even double back on themselves. So what we need to be able to do is measure all of the straight sections of the road and tally them together, and this will give us our final distance between two cities using a route. So to begin this project, we set aside a few goals for ourselves. Number one, the device needs to be simple to use. It should be obvious just by looking at it what it is, what it's for, and how to use it. Secondly, the device needs to be portable to the extent that it can be carried on one person daily. And along with that, the device needs to be comfortable enough to carry in a pocket, so we can't have any protrusions or sharp corners. We don't want this tearing up anyone's jeans. Next, the device needs to be scalable to different maps. It makes no sense to have a device that can only measure in kilometers when sometimes we have maps that are represented in miles. So it needs to be adaptable. Finally, the device needs to be marketable and profitable. Now, this wasn't called out specifically by the design document, but it's an important framework that can help us narrow down some design decisions along the way. In my research, I found several tools of the past that actually accomplish the same task, such as dividers, nautical compasses, mordant compasses, etc. As you can see, all of these devices share a pretty common DNA. We have 2 points and we have a scale in between them. What we need to be able to do is take our 2 points and place them between our two cities, compare that to the distance on our ruler, and using the scale on the map, we can find the distance between these 2 points. This is a primary driver of how our device will work. Now, to understand how our device is operated, it's important to understand how a micrometer works. So I'm going to take a few moments to explain how to read one. There are 2 primary parts of a micrometer that are very important, the thimble and the sleeve. Here's a micrometer from my shop. As you can see on the thimble, we have 25 individual hash marks. Each of these hash marks represents 1/1000th of an inch. That's 0.001. Here you can see on the sleeve we have hash marks as well, and each of these represents 25,000ths of an inch. That's 0.025. In order to read a micrometer, what we do is we tally up our hash marks on our sleeve, multiply that by 0.025, and we add that to the number on our thimble. So here in this case, you can see that we're on the third hash mark between 0 and 1. So let's tally that up. 0.025, 0.05, 0.075, 75 thousandths. We add that to the number on a thimble, in this case 0, and we have 75 thousandths of an inch. That's 0.075 of an inch. In this reading, you can see that we're actually past our third hash mark, but we're not quite at the 1 yet. We tally up our hash marks on the sleeve, 75 thousandths. We add that to the number on the thimble, 5 thousandths, and we get a reading of 0.080, 80 thousandths of an inch. Our final product actually incorporates this exact same type of scale. We even have a sleeve and a thimble. And the interface between the sleeve and the thimble are the jaws, and these are hardened and sharpened. Now, as you can see, there's a bit of a problem. We don't want any sharp corners, but we do need sharp corners in order to measure accurately on a map. So what I've done is I've actually designed the device so that when it's collapsed, it forms this nice soft bridge shape, which is nice and easy to put in a pocket and won't snag as long as they're precisely made. We even added a key ring hole for convenience. So here's a little video demonstration of how my device works. As you can see, I've got it opened all the way up, and we're at the inch mark here. When we compare that to our map, we can see that 1 inch represents 100 miles. So what I want to do here is I want to actually measure the distance between the cities of Durham and Raleigh in North Carolina. So let's take our device and line it up here. We're going to take our stationary jaw on the sleeve and put it on Durham. Next, we're going to rotate our thimble. In this case, it's just going to move straight. And we're going to put the edge of that on our second city of Raleigh. And we'll measure the distance between them using the reading on the sleeve. And we can see we get approximately 275 thousandths of an inch. So let's take our device and compare it to the scale. We'll line it up here. And doing some quick mental math, we can see that 275 thousandths of an inch would represent 27.5 miles. So what happens if we actually want to measure the distance between cities that are longer? Such as if we wanted to go from Raleigh to Wilmington. Well, let's give it a shot here. We'll line up our device. We'll set our sleeve jaw on Raleigh. And let's open up our device here. You can see we're at max dimension here. We have a bit of a problem. Primarily, our device doesn't currently reach Wilmington, so we can't measure it all in one shot. Not to mention, the road actually curves here. So what I want to do is break this down into several straight sections and tally them together. So let's give it a shot here. I'm going to close my thimble on this straight section. And let's see what our reading is. Our reading is about 275 thousandths of an inch. Let's go ahead and mark that on the map. That's 27.5 miles. Now, let's go over to the next section. We'll open up our thimble. And we get a reading of about 550 thousandths. Let's go ahead and mark this. Now we go to our last straight section here. Set up our stationary jaw on the sleeve. And you can see the dimension is actually about the same at 550 thousandths. And we'll mark it. So we've got two sections at 550 thousandths of an inch, and we've got one section at 275 thousandths of an inch. That's 1.375 thousandths of an inch. So we have 1 inch, which is 100 miles, 375 thousandths, or 37.5 miles, giving us a total distance of 137.5 miles. Thank you so much for taking the time to watch my demonstration of how my device works. I had a lot of fun designing this, and I hope I get the chance to actually make one in real life. Thank you again, and have a great day.